Hey guys, let's continue. So the last property we did was multiplication by t. So the next property is division by t. So if you have Laplace of ft is equal to fs, then Laplace of ft divided by t is given by integral s to infinity fs ds. In multiplication we were differentiating, and in division we are doing integration. If you have Laplace of ft divided by t square, suppose, then you will do the integration twice. And so on. So let's take an example. Laplace of 1 minus e raised to minus t divided by t. So first let's find out Laplace of 1 minus e raised to minus t. This is Laplace of 1 minus Laplace of e raised to minus t. So this becomes 1 by s minus 1 by s plus 1. So Laplace of 1 minus e raised to minus t divided by t is given by integral s to infinity 1 by s minus 1 by s plus 1 ds. So integral of 1 by s is ln s, and integral of 1 by s plus 1 is ln of s plus 1, s to infinity. Now, as you know, ln of a minus ln of b can be written as ln of a upon b. So we can write this as ln of s divided by s plus 1, integral s to infinity. Now since guys we have infinity, so we want to try to create 1 upon s, so we can write that as 0. So let's divide this entire thing by s. So divide the numerator by s, you get 1, and divide the denominator by s, you get 1 plus 1 by s. Now we're going to put in the limits. So when you put the limit as infinity, you'll be left with ln of 1, as this will become 0. And when you put s, you will get the same thing as before, ln of s divided by s plus 1. So your ln1 is 0. So 0 minus ln of s divided by s plus 1. This is ln of s plus 1 divided by s. Remember guys, when you have a minus sign, you can reciprocate this to remove that. So this is your answer. Let's move on to the next property. This is property number 5. You have Laplace of derivatives. So if Laplace of ft is given by fs, then Laplace of f dash t is given by s multiplied by fs minus f of 0. Guys, this is an important property. We will be using this in the next chapter as well. So remember these. So this is if you differentiate it once, but if you have Laplace of f double dash t, then you will have s square fs minus s times f of 0 minus f dash of 0. So see guys, it's following the same pattern. You just have to remember there's s square fs, then f0, then f dash 0. S square, s, and then basically 1. So remember this. We need this in the next chapter as well. So let's take an example. It says find Laplace of f dash t, where ft is sine t upon t. So first you will need to find Laplace of ft. So Laplace of ft, that is sine t divided by t. So we already did this property, division by t. Let's use this. So Laplace of sine t is 1 upon s square plus 1. So your Laplace of sine t divided by t will be integral s to infinity 1 upon s square plus 1 ds. So as you know, this is tan inverse s. Let's put in the limits s to infinity. So tan inverse of infinity is pi by 2 minus tan inverse s. So you can write this directly as cot inverse s. You guys need to have a basic understanding of trigonometry as well, because these type of questions might come up. So now we have Laplace of ft. Now let's calculate Laplace of f dash t. So this is given to you by s fs minus f0. s fs minus small f0. So this is s of cot inverse s minus f0. Now your f was sine t divided by t. So you can write this as limit t tends to 0 sine t divided by t. As you know, this entire value is equal to 1. So your answer is s cot inverse s minus 1. This is the answer. So guys, make sure you go through the examples that are in my notes, because that will give you a very good clarity of everything. Also, my notes are very lengthy. They just have a lot of practice questions too, so don't get scared. This chapter requires a lot of practice, so you can get a hang of the formulas. Let's go on to the next property. We did Laplace of derivatives. Now let's do Laplace of integrals. So if Laplace of ft is given by fs, then Laplace of 0 to t ft dt is given by fs divided by s. You do not need to do anything, just divide the whole thing by s. So for example, you have a question that says find Laplace of 0 to t sine t dt. So first let's find out the Laplace of this. So L of sine t is 1 upon s square plus 1. L of t sine t will be using the multiplication by t property. You get minus 1 raised to 1 d by ds of 1 by s square plus 1. This will give you minus 1 by s square plus 1 whole square into 2s. So your answer becomes minus 2s divided by s square plus 1 whole square. So now you need Laplace of 0 to t sine t dt. This you just need to divide this thing by s, so it becomes 1 by s minus 2s of s square plus 1 whole square. So s and s will get cancelled. Your answer is minus 2 divided by s square plus 1 whole square. This is the answer. This is a very simple property. All you have to do is divide the answer by s. Now let's look at one more property. I think this is the second last property. So this is Laplace of periodic functions. So first of all, what is a periodic function? A periodic function has a period which is suppose theta. So ft is equal to ft plus theta is equal to ft plus 2 theta and so on. It means that when you add theta, the function actually repeats and theta is called the period. So Laplace of these functions L of ft is given by 1 divided by 1 minus e raised to minus s theta integral 0 to theta e raised to minus st ft dt. So guys, the period will be given to you in the question and you just need to apply this formula. So let's try a question. ft is equal to t, where t lies between 0 and 2, and ft is equal to f of t plus 2. If you compare it with this, that means your theta is equal to 2. So let's put it in this equation. So Laplace of ft will be 1 upon 1 minus e raised to minus 2s, 0 to 2, e raised to minus st, and ft is t dt. So let's solve this. 1 minus e raised to minus 2s. Here guys, again you need integration by parts. So I'll be writing this as 0 to 2 t multiplied by e raised to minus st dt. Remember the shortcut I told you. 1 upon 1 minus e raised to minus 2s. First you write the first function, integrate the second, minus differentiation of this 1 and integration of this becomes e raised to minus st divided by minus s square, plus differentiation of this becomes 0, so you do not need the rest, and the limits were 0 to 2. So let's write this down. 1 upon 1 minus e raised to minus 2s t e raised to minus st upon s minus e raised to minus st upon s square, 0 to 2. So let's put t as 2. 1 upon 1 minus e raised to minus 2s minus 2 e raised to minus 2s divided by s minus e raised to minus 2s divided by s square plus 0 plus 1 by s square. So this is your answer. You can simplify it if you want, or you can just leave it here. You can write this as minus 2 e raised to minus 2s divided by s plus 1 minus e raised to minus 2s divided by s square. This is the answer. Now you have this one topic that is called evaluating integrals using Laplace. So for example, you have integral 0 to infinity e raised to minus 2t sine t dt. So if you remember the first formula that I showed you, which is the basic of Laplace, this one, you can see your integral is in this format. So you know that Laplace of sine t is 1 upon s square plus 1, which means integral 0 to infinity e raised to minus st sine t dt is 1 upon s square plus 1. This is the formula of Laplace. So now since you need this, all you need to do is put s as 2. So you can write integral 0 to infinity e raised to minus 2t sine t dt 1 upon 2 square plus 1. This becomes 1 upon 5. So this is how you use Laplace to evaluate an integral. You guys can go through the notes. There are tons of examples in there. So remember guys, this chapter requires a lot of practice because there are a lot of formulas and a lot of rules. Now I'll just show you guys the last property, which is Laplace of unit step function. So first of all, what is a unit step function? A unit step function is denoted by u of t minus a, and it is 0 when t is less than a, and it is 1 when t is greater than a. So the unit step function is either 0 or 1. When t is less than a, it is 0, and when t is greater than a, it is 1. So Laplace of u of t minus a is given by e raised to minus as divided by s. Similarly, Laplace of f of t multiplied by ut minus a, which is some function f multiplied by this unit step function, is given by e raised to minus as multiplied by f of s plus a. And lastly, if you have Laplace of f of t minus a into u of t minus a, then the answer is e raised to minus as Laplace of ft. So remember these three formulas, we will be using them. Let's take an example. So you have ft is equal to t from 0 to 2 and t square when t is greater than 2. So let me show you guys how we actually solve this. We are going to write this as t0 plus 0 t square. So when you add this, you actually get t and t square, right? Now what we'll do, we'll take out t common. So you're left with 1 and 0. Here you'll take out t square as common. You'll be left with 0 and 1. So you can write this as t of u t minus 0 minus u of t minus 2 for this one, plus t square times t of ut minus 2. Yeah, that's it. There's no t over here, sorry guys. So this becomes, when you're writing Laplace of ft, this will become Laplace of t ut minus Laplace of t multiplied by ut minus 2 plus Laplace of t square multiplied by ut minus 2. Now we have to use these three formulas that we have. So Laplace of t multiplied by ut will become e raised to minus s divided by 0, as a is 0 over here, multiplied by L of t plus 0, minus e raised to minus 2s, as a is 2 over here, multiplied by L of t plus 2, plus e raised to minus 2s Laplace of t plus 2 whole square, as t is 2 over here again. So Laplace of t is 1 upon s square minus e raised to minus 2s. Laplace of t is 1 upon s square plus Laplace of 2 is 2 upon s plus e raised to minus 2s Laplace of, and we have to open this. So Laplace of t square plus 4 plus 4t. So this becomes 1 upon s square minus e raised to minus 2s, 1 upon s square plus 2 upon s plus e raised to minus 2s. Laplace of t square is 2 upon s cube. Laplace of 4 is 4 upon s, and Laplace of 4t is 4 upon s square. So this is your answer. So with this we have completed Laplace transform. From the next video I will start inverse Laplace transform. And again guys, I'm urging you, go through the notes. They have lots of examples. If you do those notes, you will not require anything else at all. So if you have any doubts in this video, leave them in the comment section. I'll make sure I answer. Thank you.